So good morning everyone. Today I'm gonna be tackling about the formation of faults and folds. So the objective is to explain how the movement of plate leads to the formation of folds and faults. So stress is a force exerted on an object. In the study of plate tectonics, stress acts on rocks. So types of stress on rocks. There are two types of stress on rocks. Confining stress takes place when a rock or sediment is buried and acts uniformly in all directions. So, the pressure builds up as materials are piled above a certain layer of rock. In fact, a confining stress is related to burial metamorphism. On the other hand, is directed stress. So directed stress only acts in one direction and is most likely associated with tectonic activities. So there are three types of directed stress, which are tension, compression, and shear, or compressive, compressive, tensional, and shear stress. So these are the diagram or the picture. So compressive stress, oh wait. So compressive stress squeezes and shortens the layer of rock. It usually happens at a convergent boundary. Meanwhile, tensional stress causes rocks to be pulled apart, which fractures and lengthens the layer of rock. And shear stress acts parallel but opposite direction. This type of stress causes one rocks to slide past another as seen in transform fault boundary. So, oh my god, wait. Ay. Stress. So, rock deformation. So, the different types of stress on rocks can cause them to deform. The type of deformation that rocks can undergo also depend on the composition of rock or the type and intensity of stress. So, there are three types of deformations: elastic, ductile, and brittle. So, elastic deformation, rock returns to original shape. So, it goes back to its original size and shape once the stress is removed. Ductile deformation, rock reshapes without breaking. So, this condition where moves in plastic manner that could lead to permanent change in shape and size yet do not involve of breakage of rock. This deformation occur at area which has high pressure and high temperature. Brittle causes breakage. So this this deformation occurs at a low pressure and low temperature conditions. So folds. The series of wave-like ripples or bends formed during mountain building are called folds. Folds have different parts. So this is a picture of parts of a fold. So a faults. Some rocks fracture because of stress. A fault is a discernible displacement where rocks grind or slide past each other. So this is a normal fault, a picture of a normal fault, a picture of a reverse fault, and a picture of a strike-slip fault, an oblique fault. So, a normal fault is where the hanging wall moves down relative to the footwall. It is the product of tension which pulls Earth's crust apart. So a reversed fault, the hanging wall moves up relative to the footwall. It is a product of a compression and therefore shortens the structure. A special type of reverse fault is known as the thrust fault that causes nearly horizontal movement due to its low angle of inclination. A strike-slip fault occurs when the blocks of rocks move horizontally past each other. Move horizontally paapsiya. So, this is a product of shear stress and usually present in transform plate boundary. This can either be left strike-slip fault and right strike-slip fault, depending on the direction of movement of block of rock. And this is an oblique fault. Oblique fault has both a dip slip fault and strike slip fault. No. Horizontal and ano. But unlike faults, joints do not this implies that it involves significant horizontal and vertical movements. So these are the key points that we are going to remember. Stress is a force exerted on an object, in this case, a rock. Rock deformation involves changes, shape, and or size which can either be permanent or temporary. Folds are series of wave-like ripples or bends, and a fault is a fracture or a discernible displacement. So that is all my report. Thank you.